acceleration and accumulation of change. So the area under the curve, which is the area between the curve and the x-axis, definite integral. And then when we use that area under the curve, it can also represent the accumulation of change of a function. Remember, area above the curve is positive, area below is negative. Riemann sums, yes.
What's the area between a non-rate function and the x-axis? Like, if you have s of t equals the...
Why do you need to know this?
I was thinking about it during the test. If
You have
s
some
of t
function, but
equals the
f
amount
of x-
apples, what is the integral of an amount? Just the total
And the
amount.
integral of amount is always going to be the area under that curve. So first of all, an integral is an area under a curve. Now, if it's an integral of a rate, then you know that moving up one level is showing the accumulation of change of whatever up one level would be. Sometimes you have a function that up one level doesn't make any sense as far as the situation you're in, but it's still the area under the curve from point A to point B.
What do we represent if it's like the integral of an amount?
Integral of just like an amount is in a constant number? Or what do you mean by an amount? Like just integral of 3?
Yeah.
Yeah. Like here's 3, that just makes a rectangle
Yeah.
when you figure out the area.
But then what
But
is
what is
that?
that?
The area.
But what
Like,
No, but like,
But
she's
if
trying to
it's,
say, like,
if,
you know
it's,
I know, if you like,
if you have 3 apples and you take the integral of 3 apples, what is it?
apples
The
under
apple
an
on
hour
the side.
The
Hours
the
per
total
apple.
Yeah.
Well, no, it's not
If
the
apples
apples.
were just area.
I think in some of those situations it just doesn't make like sense. You could do
Or no, integrating
the actual rate was apples times by the input, you get a new unit that doesn't really make sense.
Yeah, right.
Yeah.
I'll figure it out.
We'll see. That'll come up on the exam, that'll be the only question.
Left, right, midpoint, and trapezoidal sums.
Trapezoidal.
The trapezoidal ones, you know that you can find the left and the right and then do the average to get the trapezoidal ones.
That's the only way I know how to do it. It's the
Sometimes Riemann sums, the spacing in between things are uniform, meaning that's like always the same amount. Sometimes if they're not uniform, yeah, it's not like we're dressed up. Riemann Incorporated.
Your average is 0.5.
I hate you.
If you get a limit of a sum, the shortcut is often think of it as the integral. Okay? The change of x is your distance along the x divided by how many intervals you have. This makes them all uniform. Fundamental theorem of calculus part 1. If you ever see an integral with an x in the integral, chances are you're going to use the fundamental theorem of calculus part 1, which means you're going to do the derivative. Okay? If you ever see something with an x that is, for example, I'll do x squared instead of x. And you take the derivative of this. It acts very similar to the original. You plug in the x squared for t, but then you also have to multiply by the derivative after. Right, because this would be a chain rule this way, so undoing it would look like this.
Why don't they write it as equals f of x times dx over dy or something? Or like x dash.
You need to know this?
Okay, so
No,
say.
it's just,
You're
it's just a question.
What was the original
It
question?
was like, why don't they write it as d over dx equals the integral blah 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 equals f of x times x dash.
Like,
Oh.
like if I make this a function like this, you mean?
This session is independent. Your question.
Yes, I suppose.
What?
Yeah,
So if this
Oh,
is,
yes, I suppose.
Yes, I suppose.
So no.
So we know that's not your answer.
But well, no.
Yeah,
Go up there, go up there,
Okay.
thank you!
Hey!
I was thinking like I'm only ready the second half.
I wanna go home
Alright.
now.
Well,
I've
okay.
given up.
So the integral from a to x of f of t.
No.
Oh my god.
Check,
No,
check,
we need
check.
to
You're writing a sentence. Oh.
I was like, times.
well, and then like,
That's
because x is a number here,
You can't.
you can, like, this,
Like last year, I'm gonna do all my pre-exams the night before.
this would be this. Okay, not x prime, because x isn't a function in this case. But if it was a function, I can write it like this, like I did above. If g of x is x, then I would have x and what?
My thought was like, cause if it's x squared, it's x.
Come on.
Kira,
Please.
I wanna go home.
Alright,
You
one more.
not need to. You already know this for the exam. We have.
Here's the fundamental Here's the fundamental theorem of calculus part 2. And
Good thinking.
This is why you do a big job.
No, they will get that paper.
in the fundamental calculus theorem of calculus part 2, we often use it in accumulation of change questions, we often use it like this. Can you see this is the same thing?
Vaguely.
I just moved the f of a over to this side. So f of b is always f of a plus the integral from a to b of f of x dx. So you have your starting point plus the accumulation of change will be your ending point. We have our properties of the definite integral. If you go from a to a, there's no area under the curve. That's 0. Sometimes you don't like the order that it's in, a to b, you prefer to go from b to a. You can do that by putting a negative out in front. You can put any value, and it even doesn't have to matter that this value is in between. But you can break up any area by going first to another number in between, and then starting at that number and doing the next part. It's just breaking that area up into 2 sections. And technically this works even if C is not in between. If you have a constant, you can pull the constant out in front. And if you're doing the integral of adding and subtracting, you can integrate them separately. If you have an indefinite integral, don't forget the plus C.
I will.
And some functions are hard to find the integral of.
Your brain was blocking that.
Because it says no one following integral.
Yes,
I don't know, maybe they're gonna ask us like.
you might need.
What is so good?
I can open the thing,
So-
or else it's downstairs.
No,
You might have to go downstairs, but if you use this key, it should open.
Thank you.
Shit.
Should.
It will.
There's no other ones.
Just call it change.
And then we had our fancy advanced techniques. Long division, completing the square. Algebraic manipulation, the trig identities.
Which is a.
These
Cheese.
are the ones you should know off by heart.
Don't we need to know like 30, 32? That was like a.
Derivatives, there's more. So in derivatives, you have more rules that, if you add the rules, we don't undo product rule. We don't undo quotient rule. We do undo chain rule, but that's substitution, but these are the basic ones. There are 16 basic ones. Of the basic ones, if you're gonna remember which ones to not remember, those would be the three not to remember.
Crossing the mountain. Oh, I'm not remembering.
Because if you know this one, if you know this one and you got a negative, you just throw that negative out in front and deal with it like this, right? Okay?
I've never thought of
Right? If you had this one, I'm like, oh, I forgot it. Well, just throw the negative out in front because you can and deal with like this one. And so often you will not see these three because they're not necessary.
Unfortunately, I have.
Should we all memorize simulation
No, I mean, all the things are negative, like cosecant squared equals negative cotangent.
Multiple choice. Do you recognize secant x tan x?
C. Secant x.
The answer is A. Derivative of secant is secant x tan x. So integrating, no advanced technique needed.
Damn.
A tank contains 50 liters at time 4 hours. Oil is being pumped out at a rate, and this is a chart of those rates. Okay? Using a right-Riemann sum with 3 subintervals, what is the approximate number of liters that are in the tank at 15 hours?
Left or right?
Right. So this jump is 3, this jump is 5, this jump is 3. We're using the right Riemann sum, so we're going to be using this first, this one second, this one third. 3 times 6.2, 5 times 5.9, 3 times 5.6 will be an approximation. We approximately get 64.9. Okay?
Oh, this was another practice exams.
What is the approximate for the number of liters of oil in the tank? What does this represent? The accumulation of change. Notice that answer is there. What are we asked to find? We're asked to find how much is in the tank. We have to take into consideration you started with 50. And you have to add the accumulation of change.
Actually go through the one that we did last night.
You don't have.
Yeah, what?
So to be careful in this question, right? First of all, there's a lot of words here. You don't want to reread it, but you should. Okay? Be also careful that while doing the work, you got the 64.9, and that'll be so tempting to be like, oh, that answer's there. I'm so excited. And I circle it.
I didn't do that. And then you guys.
That 64.9 is the accumulation of change.
Now you guys are getting what I'm saying.
What?
Just the practice exams.
That's the past.
Oh my goodness, wait. 5 to 12 is, or 7.
Yeah, you have to go, you can go.
Oh, minus 7
Go
is
my
5.
house.
Only
In my car.
So where else?
I don't know.
Using the U substitution. It's nice they even told you what to substitute.
I love when they say that.
Okay? This is equal to which one? Okay? Well, if I make U equal to the square root of x, then the derivative will be 1 over 2 root x. Does that match up? Well, I'm going to have to move the 2 over to the other side. It'll work. But where do we have to be careful is a lot of times people make the substitution and forget about the bounds. So, if my bounds were 1 to 4 for x, now in u they're going to be 2 and 1. Because u is equal to the square root of x. So it's equal to this. We look, do any of them match up? Not quite, but I can bring that 2 out in front. So the answer is C.
Kira said it was.
This is a salmon, this is a salmon, this is a salmon.
Salmon?
What exam they're on?
Oh.
We got foreign language.
This is
Salmon, salmon, purple, white, yellow.
Trout.
What's purple?
So let G be a function,
Sarah.
and the first derivative is given
One
to
is
be
white,
this.
purple is 2, orange is 3, the fourth one is.
Hold it.
Salmon was 3.
No, 4
No.
is salmon. 4 is
4 was
salmon.
salmon.
5 is
4.
yellow.
Okay, guys, let's continue on. I want to get out of here. Okay.
No, I
Yeah,
thought
I
thought
I
3
want
was
to finish questions.
Salmon is yellow orange. Yeah, but it's not orange, it's salmon.
Are we really fighting about this? Just
You
No,
see
four
the
is
X on the top?
Yes.
It's gonna make you think about the fundamental theorem of calculus.
Yes.
Which means if I take the derivative of that, it's gonna go away. The derivative of that will be G double prime, and I notice all of these things talk about concavity. Right? This is, yes, this was on one of the exams. This is the graph I'm dealing with. First of all, G double prime of x from the fundamental theorem of calculus will be e to the negative x squared. And e to anything is always positive. So that tells me I already know it's concave up. Right? But now I'm down to these two.
B is also.
In order to find out about G, I need to find out if G prime is positive or negative. Right? Because if I want to find out G is decreasing, this one implies that G prime of x is negative. This one implies G prime of x is positive. What is G prime of x? G prime of x is an area function. And if e to the x is a positive graph, my area as I go from 0 to the right is going to be a positive number that keeps getting bigger. So because it's a positive number that keeps getting bigger, I know that g of x is increasing. That part is the hard part. The double prime part wasn't too bad. At least you get to a 50-50. But the increasing.
Can't you go by the
All right.
Oh.
Here's a graph of f. Again, we see the 0 to x. So right away I'm thinking fundamental theorem of calculus. And I know that h prime of x is f of x. Now they all deal with sixes. So if I want to find h of 6 will be the area under the curve. And that area is below the x-axis. That makes that part negative. H prime of 6 is the derivative. H prime of 6 is f of 6. What is f of 6? It's equal to 0. H double prime of 6 will be f prime of x. H double prime of x is f prime of x. So h double prime of 6 will equal f prime of 6. F prime of 6 is the slope of this tangent on here, which is positive.
I feel like
Okay?
oh,
I don't know if you've noticed, but most often in these kind of questions, one is negative, one is 0, one is positive.
My experience will. Oh, like the value is like 1 0. myself.
You just said that.
I know he said usually I said advice.
It's always
all the
been.
time.
All the time.
You just look like there.
Sometimes I've seen ones where it's obvious that one
Talking
is
to myself.
much more positive than another one. They could do that.
Oh, yeah.
Or they could make it like such a slight
Like this, the
difference.
one slope is like this, and the other
And then
slope
the
is
slope
like
is like
this.
that, yeah.
What was the average for the test
Yeah,
last
why don't
year?
you just actually do the
The
work
exam.
instead of figuring out?
I don't remember the average for the exam last year. I do remember that of the 27 people that wrote last year, 14 got fives.
Whoa.
That's gonna be us.
We're lower in that score. 4 or 5.
And then
I love you.
I think another 8 got 4s, so 20, like 22 out of 27, or maybe 23 out of 27 got a 4 or 5. Something like that. So you've had a similar experience as far as all the work that you've done.
My 18 was like 11.
When you get one, you're like, wait, that's it.
We have so
Yeah.
much.
First place.
Our grades is just-
The only thing that their class didn't get that we've done a lot this year is really, like, we found out their mistakes and we've told you guys a lot of what they made.
So you're gonna do that for next year?
So next year there's gonna be so many things we're gonna.
Oh, yeah.
We need a whole other period
My
to just
gain
recap
is
what we
not
did
their
for all
gain,
year.
okay?
We all get everything wrong then.
F prime of x will equal g of x,
Careful.
which could be the graph of g of x.
A.
And that just has a positive slope. It's going to be constant. The answer is A.
Alright, we're all help.
Yeah. What's the difference?
I go,
Have they all been A's? There's been 3 A's and 1 A's.
Ooh.
This is a Mr. Vincent test.
No, this is Mr. JR's quiz.
There's
Oh,
A
okay,
and
okay,
C.
okay.
All A's, yeah.
Mr. Vincent's only these.
Alright, water is pumped into a tank at a rate, so we see that this equation is a rate already, gallons per minute, where T is the number of minutes since the pump was turned on. If the tank contained 800 gallons of water when it was turned on, how much is in the tank after 20 minutes? So if we take the integral from 0 to 20, that will give us the accumulation of change. And we're going to have to add that to the 800. So our 800 initial plus 0 to 20 of that rate.
I'm at 6,000.
Oh, it's not A anymore. Sorry, guys.
That was right.
Really?
Yeah.
You don't say.
When you write an F, it's like that.
How did you
Something went wrong on the calculator?
I don't know how you got that, but you're fine now. It added a bunch of zeros after it.
What? Oh, that's what I did. Must be good.
The particle moves along a line, and they give us the equation of acceleration. If the particle's velocity at time 0 is 5, what is the velocity at time 3? So it's accumulation of change, right? Because if we do the integral of acceleration from 0 to 3, we'll find out how much the velocity has changed. We know we started with 5. I would probably go directly to this, that V of 3 will equal starting at 5 plus the change from 0 to 3 of A of TP. Because you always have your starting point plus your accumulation of change will be your ending point.
What?
And notice they gave the answer if you forgot to add the 5. Just the integral will be the 6.710. So you have to read the question, because this question could say, how much has the velocity changed between 0 and 3? Then the answer would be the 6.710. But it's asking what is the velocity. A rain barrel collects water off the roof of a house during 3 hours of heavy rainfall. And they give us a rate in feet per hour. Whereas t is the time since the rain began. At 1 hour, the height is that what you say with a decimal? Do you say foot or do you say feet?
Feet.
0.75 foot?
I think it sounds
What?
good.
Sounds
better.
It's not more than one yet.
It's feet.
That's good.
So what happens if it's negative? Negative 2 foot?
-2.
That
Can you
doesn't
have
make
a
sense.
Can you have
negative
negative
amount?
feet?
I think it's like how you'd say like half a dollar, not half a dollars.
Adult, like what?
Well,
You say half a dollar, so I could see
It's
0.75 a foot,
a foot.
but then something would seem a little bit.
Something that's
Okay. So what do we got? We take our starting point. We do the accumulation of change from 1 to 2.
My feet.
Oh my god, look at how big Zoe.
If FT is the abbreviation for feet, what is the abbreviation for foot?
Sarah, stop.
The same thing.
What is perfectly normal?
You think that was proper? And you were like,
What the hell are you saying?
I don't know.
I think, I agree with you, that's not more than one, so we can't go plural. But less than one, I think they should be called fonts. It's not just foot.
Oh.
What happens if it's like 1.1 feet?
It's still over one, you can go feet.
Okay, okay.
Yeah, it's plural.
So if
Foot
it's
is only when you have exactly one.
okay.
There we go. Okay, honey is poured through a funnel at a rate. Ooh, we've got another rate here. This one is just looking for the accumulation of change.
Looks like people gonna watch this video.
So notice it says how many ounces are poured through from 0 to 3. It's just looking for the accumulation of change. We actually didn't, this question would be more mean if they had said at time equals 0, there was, I don't know, 3 ounces of honey in the container. You don't need that information, but that could throw you off on this question.
The gravel.
Me
We made that mistake.
Me on the test.
We did make that mistake. They tricked us. Big calc tricked us.
You would have been doing
What?
The figure shows the graph of f prime. Twice differentiable means
I didn't say.
super continuous. Super
It is continuous square.
It's super continuous.
I think.
The areas of the region is bounded by the graph of f prime and the integrals are, so this is 2, this is 6, 0 to 1 to 2 is 6, this is 10, and this is 14. So here they're saying the area bounded by the curve and the x-axis, then you always are considering those areas as positive. Okay? The graph of f prime has horizontal tangents at 0.6, 1.6, 2.5, 3.5, and it is known that f of 2 is 5. Evaluate the integral from 0 to 4 of f of x times f prime of x. This is a little bit interesting notation.
You sell.
What's that?
You sell.
You sell. We like equal f of x. du will be f prime of x. What do you have to be careful on in this one? The bounds. This is wrong. What did I do? I didn't change the bounds.
Wow.
Okay? So do I know?
What did you say? He's threatening us with
So in order, like, technically, I should have just done this. Right? Because I don't know how to change the bounds.
And then this balance.
Or, technically, I could have also done this and not been wrong. Okay? But instead of 0 here, I could put f of 0, and instead of 4 here, I put f of 4. That also would be okay. But once you substitute back, we can go back to the 4 and the 0. Those values are all given to us. How do we find f of 4? They're not really given to us, but we know f of 2. F of 2 is right here. F of 4 will be the accumulation of change, so we'd have to add 10 and subtract 14 and get us 1. Does that make sense?
Subtract.
Or just add -4.
And f of 0, if we know f of 2, f of 0 plus 2 minus 6 would be 5. So we could work backwards and add 6 minus 2 to get f of 0 to be 9.
And 9 squared is not 16.
Okay, I understand.
So 1/2 minus 81 over 2 is 40. Negative 40.
This is completely, you were doing this to yourself.
No, the shame would just kill me.
You walked over.
We have to do softball this time.
Wait, what's the answer?
Yeah.
But?
Yes.
Yeah, it was so
Can you go back?
I can go back.
It's mostly in the bottom.
And poured all of this water.
Like, what does that mean? Like a black hole? How do you get it?
Look at that, bro.
We still die.
Look at that. It's not even under your foot, so we.
Whoa, angry.
You're like rubbing your foot around your
think
As we enter the third hour of the Celtic review, tensions are rising.
Faster than time.
There's a lot of surface area.
Are you good?
Okay. There's a million times in that bad boy.
Ooh, no calculator.
Especially like that.
Where'd you hear on this?
We've got a differential function f, so we know it's continuous from -3 to 3.
Integral?
Horizontal tangent lines at -1 and 1 and 2.
What did you guys learn last Sunday?
Last Saturday.
Zoe, what did you guys learn last Sunday?
5, 4, 5, 3. Let's add those.
Thanks.
in.
Thanks. That was helpful. Lazy optimization.
Differential equations.
was today.
Derivatives? Yes.
What is-
The basics of
Like the
derivatives.
basics of derivative, like L'Hopital's rule.
So I didn't miss anything. Okay.
Well,
G is the antiderivative of f.
We'll see, we'll see.
such that g of 3 is 7. Let h
Yeah.
be the function defined by h of x equals 3, f of 2x plus 1 plus 4.
On the way up, that's the only high five.
Whew. Does that look extra complicated?
It's a long equation.
And we need to find the value of negative 2 to 1 of h of x. So,
Oh my god. No couch.
what can we do with this? We can pull out the 3. We can separate the plus 4 as a separate thing. In fact, this is the easy part of the integral to do.
I always forget you can integrate by parts. Or whatever.
Well, it's not integration by parts, but it's
Sorry,
separated.
separate, guys, sorry.
If we do a u substitution here,
Hello.
What could possibly be going on?
this is hard to visualize because you're gonna have a horizontal compression and a horizontal translation, so it's easier to do a u substitution. If we do that u substitution, then our bounds are gonna change to negative 3 to 3. And this just becomes everybody's favorite function, fu, times 1/2 du.
Whoa.
What possibly be messing up right now?
What?
I didn't do you substitution.
Plus
How'd you solve it?
I don't think she did.
I
Secret
secret
third.
Secret third. I just did the big F to the
big
F.
this part off to the side is why that's 12, right? The integral of 4 is really easy because it's just gonna be 4x.
That's really hard.
I can't.
That's difficult.
Everybody's passing.
Oh my god.
Wow, messed up.
Since you were waiting, let's not even the glass.
The integral of f is going to be g. So if we want to go from negative 3, here's f, f is given. If we want to do the area under here from negative 3 to 3 of f of u, we're just going to add up all those areas, right? 5 minus 4 plus 5 plus 3.
I'm just gonna leave it like this. Just gonna circle what it says.
I will leave it as the 3/2. Circle 5 minus 4 plus 5 plus 3.
I'm gonna circle
Because that's like 3/2.
What?
No, just leave it up to you.
Yeah, leave it at blue.
Oh, 2 more
Why?
questions.
This is
Oh
all
my
the marks, guys.
Wait.
You're not getting the marks anyway.
Oh, okay.
There's no more marks in blue.
When I already did zero, so
Mr.
I
Jack,
have-
we have
I have
tests
a-
after this.
The second you
Like we
log
need to do
in,
a
you're
test
already
on
got a zero.
like vectors and stuff.
Yeah, we'll have a test on matrices and test on vectors, but no exam.
Is there a reason to be doing tests? Like, can we just not?
You want to do the exam instead? Okay.
No, can we just not do
Thanks,
either?
Yeah, not gonna leave.
I'm only 2 units, it's just a good test.
Can I take one?
Instead of 2 tests.
Can it be a take-home test?
Can it be a group open book test?
Open the test.
I think I'm gonna do
Uh,
worse.
I'm literally
You got falling on top.
Oh.
Someone,
Calculator question. The height of water in a conical storage tank shown above is modeled by a differentiable, hence continuous, function h.
that is my martini glass.
H of t is measured in meters and t in hours.
So funny.
They give us the derivative
Got a wine glass.
nicely for us here, h prime of t. Meters per hour from 0 to 24. What is the minimum height of water during this period? So, do you see that this is an EVT question?
Oh, no.
Okay, but you would have to make sure you say this inside that question.
Ow. Oh, I'll just take
What? Huh?
I'm writing it with a long
Stop stealing my stuff, that is my property.
I can use, that says,
Jealous.
that says can use
Give it to
EBT
3.
because continuous.
Give it to
I don't know if
you.
it's because.
We'll say it says that.
Oh, you didn't even have to
That's what it was meant to
Can I
say.
do that on the exam?
We'll
say it says
Respectfully, I meant that
Like a
though.
decimal
Use the
point.
visible to
Okay, like a point oh.
Yeah, can I use invisible
Okay.
ink?
Let's-
K.
Gay.
Okay. No, you said gay for sure.
Oh, you said gay.
Okay, whatever.
Oh, what is
What are you
What is it?
Just
Okay,
have no, just oh.
You can use ERT. Come close.
It's giving.
Come close.
But
So we need to set our derivative equal to 0 to find the critical point.
I'm like touching
It's a calculator question, so you can find this equal to 0 from your calculator.
Is that like the zero?
It's just the x, it's just make it equal to 0 would be an x-intercept or 0. Okay? That's our only file. We have to check our candidate points with the extreme value theorem. But if you just said this, if you failed to mention the calculus,
Oh, yes.
if you failed to mention that, you would lose the continuous that you're allowed to use the EBT. So in order to use the EBT, you have to say it's continuous. The question did not say it's continuous. It said it was differentiable.
What that means.
So can
But
you literally
you
write
have to
it's
say-
continuous?
You have to say differentiable implies continuous.
Can I write
Therefore, we can
Can I
use.
just
Can I write constant?
It's
You
okay.
can write. You can already call those, right? I think there's going to be countless times you can use that in the future. So then the minimum is the 16.339. Make sure you have the units there as well. A line tangent to the graph at t equals 16 is used to approximate, so linear approximation seems to be coming here. Use the tangent line approximation. At what time does the height return to 25 meters? So what do we need to have our tangent line?
Point slope.
Points and slope. There's our slope, we can get that, we have the derivative. How do we find the point? Well, that's right here. I can plug in 16 for t and use my accumulation of change. 25 plus the accumulation of change from 0 to 16. Once I have that point in my slope, I can write my equation of my line. All of those decimals. And I want to find out when it hits 25 meters again. So what am I solving for? I'm solving for the time. So the 25 goes in for the y.
Oh, yes.
And you get 17.258 hours.
It's really good.
Still solving A.
Oh god.
One more.
Home structures.
Yeah.
I'm ripping out. I may have to guess because I'm writing at about 18%. So 18. 8 is on its feet.
You're just gonna drive out there, else they're
Oh, it's on my Yeah, like 4 U's to keep
All right, everybody ready?
Yes.
Last one.
Let's do it.
Oh, that looks so short. Let's go.
Let's go.
They're so short.
On a certain weekday, the rate at which vehicles cross a bridge is modeled by the differentiable, hence continuous, function r, where r of t is measured in vehicles per hour, and t is the number of hours since 7 a.m. And we've got selected values there.
Building a calculus.
This is a rate. Do you see that it's a rate?
Yes. Yes.
Okay. Use a midpoint sum with 3 sub-intervals of equal length.
Oh, yes.
Okay? 3 sub-intervals. Look at that. 0 to 4, 4 to 8, 8 to 12. Don't get confused by the fact that there's more numbers. Each of those intervals are
2.
4.
That's crazy.
Whoa.
And 4.
Oh, what?
Right? And this would be the midpoints.
What numbers?
That's why those extra numbers are there, so you have the midpoints.
Oh, that's nice.
Yeah, it is nice.
Divided.
So we take 4 times that middle number, plus 4 times this number, plus 4 times that number.
But the real question is, what day of the week is it?
It's Thursday.
No,
Thanks,
is the question, Sarah.
Is that all the work you need to show?
That's all the work you would need to show.
Because before we would do like the summation.
We need a big one.
You don't need to do that yet?
Ah.
You don't need to like chapters 2 or like any of that, you can just put them.
You can just put, you know, you've got it up there. What does this?
On what test though?
We're done by 15 minutes early.